Perspective Class 2 Video 3. In this video we're going to continue talking about lines and pairs of lines. The first thing I want to talk about is an important theorem for calculating the equation of a line. So this theorem says that the equation of a line through 2 points, the point x1, y1 and x2, y2, is y minus y1 equals mx minus x1, where m is the same thing we said it was in the previous video. It's y2 minus y1 divided by x2 minus x1. Okay, so this is a very important theorem because it lets you calculate the equation of a line if you only have 2 points. So let's go straight into an example of this theorem. So this example simply says find the equation of the line through the point 0, 2 and 3, 8. So what you do is you let 0, 2 be the point x1, y1 and 3, 8 be the point x2, y2. It didn't actually matter which way round. I could have done these the other way around as well. It doesn't matter. And then you just apply this theorem. So you use this equation. So the equation of the line is going to be y minus y1, and y1 is 2, equals m x minus x1, and x1 is 0. Where if we remember, m is going to be y2 minus y1 divided by x2 minus x1, which is 6 over 3, which is 2. So that means that the equation of the line is y minus 2 equals 2 times x minus 0. And if this was the question you got in the exam, then this would be a sufficient answer. But sometimes I might ask you to give me the equation of the line in a specific form. So I might ask you to give me the equation of the line in the slope-intercept form. In which case, if I was to do that, you can't stop here. You have to continue doing some more work. So you have to say if this is equal to y minus 2 equals 2x, which is equal to y equals 2x plus 2. And now that's in slope-intercept form. That's the equation of the line through these 2 points right here. Okay, now I want to talk about pairs of lines. So this is simply just a definition, and it says lines with the same slope are called parallel, and lines that intersect perpendicularly are called perpendicular. So parallel lines will be lines that look like this. This is parallel on the left, and perpendicular will be lines that look like this, where this is a right angle. Okay, so it's a way of relating two lines to one another. The next thing I want to mention is just a theorem. And this theorem tells you algebraically when lines are parallel and when they're perpendicular. We know the geometric interpretation. This is the geometric interpretation right here. Parallel means that they both go in exactly the same direction, and perpendicular means that they intersect at a right angle. But algebraically, this is what it means. So if I give you two lines, and I'm going to give you them in slope-intercept form. So one line is y equals mx plus b, and the other line is y equals m prime x plus b prime. These little apostrophes, mathematicians call them prime. Okay, so it's just a way of me denoting that m prime is a different variable to m. Okay, so that these two things be two lines. Then they're perpendicular if m equals m prime, and they're parallel if m equals minus 1 divided by m prime. So this one's definitely the more confusing of the two. Parallel means they have the same slope. Perpendicular means they have the negative reciprocal slope, which is just a fancy way of saying m equals minus 1 over m prime. So this is an equation that helps you tell when two lines are parallel or perpendicular. I'm sorry, this is a theorem that helps you tell when two lines are parallel or perpendicular, or neither. So let's look at an example. This example right here, very quick, it just says y equals 3x minus 1 and y equals 3x plus 17, they're parallel. And you know this because 3 and 3 are equal. right? they have the same slope, so they're parallel. In the second line, y equals minus 2x and y equals a half x plus 4, they're perpendicular. And why is this true? Well, minus 2 and a half. If you think about it, you could do this either way. You could say a half is equal to minus 1 divided by minus 2. Okay, i.e. m is equal to minus 1 divided by m prime. So these two slopes, they satisfy this equation right here, which means that the lines are perpendicular. The last thing I want to quickly mention is, it might seem obvious, but I want to just mention it anyway for completion, is that any two vertical lines are parallel, or respectively any two horizontal lines are parallel, and any vertical line is perpendicular to any horizontal line. So this is, I think this is obvious, but I wanted to just mention it anyway. So any two vertical or any two horizontal lines, they're parallel. And then the second part just tells you any vertical line is perpendicular to any horizontal line. Okay, that's all this theorem is saying. So that's the end of this theorem, and that's the end of this video.